So hi, everybody. In the spirit of being more inclusive, I'm going to ask you guys a couple of questions. And obviously, throughout the whole process, we're just going to talk to each other. And the reason why I make this very explicit is that if anyone wants to jump in and explain certain concepts, feel free to do that. OK, so who of you in this crowd actually has developed in a functional programming kind of style? Awesome. All right. And of you guys, how many of you have actually heard concept like Lodash, Ramda, underscore type thing? OK, we're not going to be talking about any of those libraries, but hey. All right. As you can see, this is a Deadpool-inspired talk. So if you do not like Deadpool, this is going to be an extremely terrible presentation for you. Because like, you simply won't get the jokes. And that's fine. Also, it's not a train smash. But yeah, just like make yourself ready for that. All right. Cool. So in the spirit of being more Deadpool-ish, right, just imagine, right, that Celine Dion is singing in the background as I introduce myself, right? Who am I? My name is Ruddy. I am a software developer. I touch a little bit of back-end code, touch a little bit of front-end code. So I'm just very handsy, and I like touching. So yeah, that's me. And the other ones are just for an effect to get you guys laughing. All right. So in the spirit of Woman 365, I'd like to send a shout out to these ladies over here and learn their Twitter handle and like follow them. They really have interesting stuff to talk about and say and worth listening to. So yeah. Now, we are here to kind of have a high-level view of what functional programming is. In my life, I decided that maybe it will be really a good thing to start actually understanding the code I produce and what kind of effects it has in the outside environment, basically, right? And if you were to take one thing out of this talk is basically the idea that you can start implementing or start programming in a functional way right now with what you can have like out of the box from JavaScript. And I will tell you and show you what the exceptions are where you start using like libraries and all of those things. But you can theoretically just do and create your code in a functional programming way. Now, Wikipedia tells us that functional programming is a paradigm. And what basically that means is it's a way of viewing your code or structuring your code. It's not a different language, and it has existed for the longest time. So it's just basically how you reason about your code, right? And the next section, it talks about that it treats computation as an evaluation of mathematical function. When people see this in a definition of functional language, they really, really think that it's very tied up to how mathematics is. And by mathematics, in my head, I'm thinking calculus. And though the principles are the same, I'll kind of explain to you what it means, right, in that context. And the last part is that it tries to avoid state, highlights on avoid, right? It means that, we'll get into it as well, but like it tries not to mutate state, at most control, when it actually does that, right? In my journey of figuring out and trying to be more functional, right, I went and I looked at this guy called Nathan Taylor. So he has a plural course, right? And there he kind of says something that is very powerful and that resonates with quite a few of us, right? Functional programming helps you to reason about your code. And what basically that means is that I understand, I have a full concept of what this function is basically doing. And therefore, if someone were to ask me exactly why did you do it and why you did it this way, I can tell you what's actually happening because it makes sense to me. It has its own state, like the way it handles its own parameters, the way what I'm getting out of the functions is kind of something that makes sense. So I can tell you what my code is doing. And we fall very a victim of this kind of like way of just producing a solution, right? So we've got a bug in our system and all we want to do is just find a solution. We're not actually taking like the precautions of figuring out what we're doing and what it's actually affecting in the greater part of the program. And now you find yourself with like random bugs and you kind of don't understand where they come from. And you spend a very long time just trying to debug code and kind of figure it out, right? While with functional programming, and hopefully by the end of this, you will see why it kind of helps you to understand your code structure and prevent things like stupid bugs. All right, cool. OK, so the first part of the definition of functional programming is that it's a paradigm. Now, JavaScript, being this amazing beast, right, supports quite a list of these paradigms. One of them being imperative programming. So imperative programming is very pedantic on detail. It is like a command-like creation of your code. So what you do is that I start doing this, and then when I'm done with that, I'm going to do this. And in order for me to get this, I need to do this. So it is the how as to how your code is actually going to do or achieve something, right? So that's imperative style of programming. And the problem with this is that each and every one of these this, that, what, and whatnot maintain their own state. So if they do that, that means that if ever your program were to be larger, it'll be a lot harder for you to keep managing the state. So to answer that question, we then created object-oriented programming, right? And the idea of this is that we're going to have these little instances and objects, and we're going to package them up together. And each and every one of them are going to have these tiny states, and they're going to communicate with each other, passing messages back and forth, right? And this kind of allows us to maintain state a little bit better and have like a bit of a structure in our code to kind of visualize what our code is actually doing. As a pause, right? Disclaimer, I'm not going to do what Mimi did. I don't have like a program that's going to have a wow factor at the end. So in case you're waiting for that, I'm sorry. There's going to be like a lecture-ish kind of vibe, so I'm sorry about that. Cool. And then we continue. Metaprogramming, right? In my quest of trying to figure out how functional programming works and how to actually start using it, right, I came across a book called Functional JavaScript by Michael Fergus, I think. Now, Michael Fergus says, what is metaprogramming, right? And he says, programming occurs when you write code that does something. Metaprogramming occurs when you write code that changes how something is interpreted. So I'm going to say that again. Programming happens when you create code that does something, but metaprogramming happens when you create code that changes how something is interpreted. I have a few examples of this, and I'm going to show you if you are interested, and we can talk about it later on. But this drives us to the next amazing thing, which is declarative programming. In opposite to imperative, declarative programming says, I don't care what you do with the code. I just want you to do something for me and give it back to me, right? So functional programming is really closely linked to what declarative programming is all about. And the reason why I say that is because functional programming says, I really actually don't know I don't want to care about the how. I want to care about the what that I'm trying to get out of the program or whatever I'm coding, right? And yeah, so let's just look at a few examples. The two distinctive paradigms are these two, right? So imperative is the how. If you looked at it, it's a normal for loop, right? I'm going to declare a block, which is a for loop. In it, I'm going to declare an iterator, which is I. And I'm going to go to my squad, right? Which is an array, and loop through it, find an attribute called last modifier, and assign a date to it, right? Declarative programming then says, I really don't care how you do that iterator. There's my array, go do something, in this case map, which is going to go and iterate for you through your array, and then go and find an attribute called last modified and assign something to it. So you can see it's still in JavaScript, but the behavior and the way you're thinking of your code is a little bit different. Cool. Now, the other part of this definition was that it treats computation as an evaluation of functions, right? And in its essence, in its core, what it says is that every time I call a function, it should give me the same information back, right? And just like a mathematical function, this simple f of x function accepts a value called x, and then will multiply whatever that value is by 5, right? And you're going to pass this parameter to this function, parameter being x, right? So I am going to give you x, and in this case, my x is also 5. And I know that in your function, you're going to multiply that by 5 and give me a response. This is very linked to the concept of pure functions within functional programming. It says it only depends on its parameters, and give me those parameters to work with, right? And I'll give you a returned object back. And you can predict what is going to happen in that function because you're looking at it and it makes sense to you. So I'm going to create a function that accepts a parameter that is x, and that x is going to be multiplied by 5, and it's going to return a value to me. And that's what it means by this teaching computation as evaluation of maths. Cool. And then the last part of the definition is mutable data, right? So functional programming tries to not mutate data, right? A thing that we do miss in JavaScript, and that's why sometimes it's like the bad of JavaScript or the bad side outside of global variables, right, is the fact that we assume that calling functions like sort actually don't modify the initial array or the array that it's working on, but it does. So when you have an array, in this case key, and you're trying to sort it from 1 to 8 or whatever, right? When you run that code on sort is actually going to modify key, right? And when you return this, you wind up like, hey, I've got this new array, but actually you modified the previous, or the array that you were working on, right? There are very few attributes in JavaScript that are immutable, and string being one of them, but arrays are not. All right, cool. Now let all of that definition sink in, and everybody understands what I'm talking about, and I'm not talking too fast. Why do we want to do this? And to people who actually use functional programming, why do we want to do it? Why do you choose using functional programming as your style of code?
Why are we using immutability, or why are we using our style of code?
Functional style of code, so pure functions, not mutating data. Why do you choose to use the functional style of code? Yeah?
It breaks down the problem in smaller parts, and then it forces you to or name something and extract it into smaller parts, so you don't have this Goliath of a function.
Awesome,
Well,
yeah.
I find that's what it does for me, at least.
Awesome, okay. That's actually true. Yeah?
I'm guessing just from that imperative versus declarative comparison, it also helps with readability of code.
Exactly. Awesome, yeah. Cool. Everything that the guys just said, right? And the fact that, first, functional programming is not new. There is support, there's resources around, and you can start just using it, right? And people and their resources, easier for them to explain certain things. It has just existed. So it's not something that needs to be like this, I don't know, something you go for a retreat for and whatnot. You can just start using it because it's JavaScript that you use every day. You're just really smart about using it, and you're understanding why you're using it, or like using your functions that way. Secondly, it's easy to reason about your code. I already mentioned this. But something that you mentioned, right? Simplifies complex touch points. When you, I don't know if you guys have had this experience, where you go to some project and they've got this code that looks like it's doing too much, the functions are long, and every time you're trying to debug something, it just takes the whole day type of situation. So because you can break apart functions, you can actually like be in control of what that function does, because you actually are giving the parameters that it needs, and it will always respond to you with an array. You kind of know that, okay, cool, I've got this function that does this. I've got this function that does this. I can put those things and pipe them together and change them together, but they all form these individual parts where it's easier then to follow how the code is going, because sometimes you really read code that is really, really, really bad, and it takes way too long for you to get your job done. So if ever we kind of implemented this, it will make our lives easier. Cool. Another thing, reusability. So in reference to the previous example that we had with declarative and imperative, right? The first one explicitly took a value of 10 that it iterated through, right? So that means that if I were to put that in a function, I can only iterate 10 items. But with the way functional programming and the way you think about your code, it allows you to create a function set that if you don't want to pass 10 today, you can pass 100 tomorrow. You can do this because it can handle all those things. Because you're not worried about the how. You just have a thing that you want to achieve, and you are kind of, being explicit about it. Right. And then testing. I am going to take some time in actually talking about this. Well, not a lot of time, but based on how pure functions are, right? When you test code, it's going to be a lot easier because you don't have to start mocking information or mocking these dependencies or data calls and whatnot. You give the function what it needs, and then it computes something, and you check if ever the response is what you expect. Last thing, it's technically not faster. So, and the reason why I say this is, and everybody can obviously jump in, right? When you see a for loop anywhere in your code, you have an opportunity to be recursive. And recursive means calling your function over and over again. That really, really, really plays on your performance, right? Another thing, for the sake of not being or trying to be more immutable, right? You will be creating these objects and creating a copy of something at some point. And that really works your garbage collector. So it's out here trying to create state-free memory and all of that stuff. And because of that reason, I personally don't believe that it's faster. But what it does is make you a better programmer, well, a faster programmer. Let's not say better, because you guys are great. It creates, because your mental map and how you put things together kind of makes some logical sense. It's easier for you to start creating code, and code that you fully understand, because you kind of have a grasp of the simplicity of how functional programming is. Cool. Now, with all of that said, just let it sink in also, because like there's levels of how deep you're going to get with this. So I needed to get in there. All right. Right, so let's talk about pure functions. What are pure functions? Okay, pure functions first depend on the parameters or what you pass it. They always give you a return value, so void is technically not a pure function. Does not use global variables because it really tries to avoid mutating a state around it. So having a function that does a console log, for example, is kind of not a pure function, because that thing is influencing a state outside of that function's environment. And that is not what we're trying to do. We're trying to avoid that as much as we possibly can. Okay, examples of a bad function. Now, what you see here is Deadpool's squad. It's an array of objects that takes in Lucky, Peter, and Deadpool. In there, they've got superpowers. And we've got this function called Let's Fly. Anyone who watched Deadpool really should get this. But anyway. So we've got an access to this. Can you see my cursor? Awesome. OK. This array here, which is actually a global variable. We are going into it and then going and finding superpower and adding 1 to it. And then after that, we go and, in this if statement, put a condition and say if the superpower is greater than 20, then the hero gets too much strength and self-destructs, right? And what you do is take the first value out of that array and remove it. This is a horrible code, guys, but I'm just driving a point, so bear with me. Right? And then after that, it does this console log out. After the definition of what a pure function is, we already see how many things this function is violating. First, going and using a global variable. Secondly, does not return anything. Thirdly, changes the environment around it. So it's not a really, really good example. Then we come to the awesome, right? Again, we've got the object. We pass in Deadpool. You don't necessarily need to create the copy, obviously, because you've got the variable here and it's individual from the global one, but I did it anyway, right? And then you use that, go and get power and set 1 to it. Still do the shift, but then you return an array. So instead of having to modify the initial Deadpool squad, I now have a new array that doesn't have a first value because that first value failed superpower test, whatever, right? So that's like an example of what a pure function would look like. Secondly, and now we get into mutation, right? As I said earlier, JavaScript doesn't have a lot of data types that are immutable, right? So strings allow us to be able to be more functional because they are immutable. But when you do and work with arrays, you just now need to start being smarter. And in this case, we're just defining a sort that is immutable, and you can implement it in a way that you wish, and basically still maintains the first array the way it was originally, and then the second part of the array, which is now sorted. All right. So before we get to the second part, that is the two major thing about functional JavaScript, right? Which is like the pure functions and how not to mutate states. And that's just like a good basis. And before we get into how we can make our functions less complex and breaking them apart and doing really, really cool things about it, that's like the basic, right? If you wanted to know what it is, they got it. And you can start doing this in your code right now. You can start controlling how your functions are mutating state. You can start controlling what you pass into your function and what you get out of it. Something that you can do today. In a spirit of being inclusive, if you look at this code, right, we've got var birth that has 5 to it. And then we go and create a function called add power. And add power takes in a variable called by birth. And then inside of it has an inner function that takes by mutation and then adds by mutation with birth. After that, we interact with our function. Add power, we pass 10 to it. And then this will return the function, and we pass 20 to it. So my question to you guys is, what would be the output of increased power, or after we run increased power? Everybody else who knows what this concept is, keep quiet. So just guess. Okay, go. Nothing? Nothing? No? Guess. Go ahead.
I would go with 30.
Okay. Any reason why?
I subbed in 10 in the first one, and then I put 20 in the second one, and added them together, and then made 30.
Okay, cool. That is a correct answer,
Oh,
by the way.
sick.
No. That is actually a good answer. So I'm going to explain the concept of what's happening here. But before I do that, I'm going to take you guys onto a journey. So please hold on to your hats, because I'm going to go places, right? And hopefully I land in the right place. OK, cool. Now, JavaScript is actually compiled, right? It has this thing called just-in-time compilation. We all believe that it's transpiled, and yes, there's some truth to that. But there's a certain part of it that is actually compiled. And that the process where that happens, and just before your application executes, what your engine does is that I'm going to have all this source code, and we'll take by birth that assigns 5 as an example, right? It'll take all your source code and says to the compiler, hey, compiler, there's your source code. Compiler then goes and says, hey, I've got a variable called by birth, right? Scope, do you have by birth? And scope is like, no, I don't. And compiler says, OK, cool, create by birth. Now in our scope, we've got by birth, right? The engine comes back and says, I've got this int variable value 5, and I need to assign it to something called by birth. Scope, do you have by birth? And scope says, yeah, compiler told me to create that later, or like a little bit earlier. So I've got by birth. And the engine's like, OK, cool, I'll assign 5. If your engine did not find by birth at the innermost scope, what it will do is go back to the outermost scope and ask, outer scope, do you have by birth? And outer scope is like, I don't have by birth, right? And goes all the way to the global scope, right? And now I'm going to take a time to actually tell you why your code needs to be in strict mode for this purpose. When your engine goes to the global scope and says, hey, do you have by birth? And global scope says, I don't. If your code is not on strict mode, your global scope will say, but I can create it for you, because this is what I do, right? And if it does that, now you've got by birth that exists somewhere in a global scope who you don't know also has access to it. And if it changed, could really affect your code, right? But if ever your code is in strict mode, global scope is going to be like, no, I don't have it, and there's an error, right? So no one has by birth, no one is going to assign anything. And just hold that concept lightly in your head, right? JavaScript in its essence has something called lexical scope. And our lexical scope is an opposite of dynamic scope. And what that means is, what dynamic scope is, I will figure out the scope of an object during runtime. Lexical scope says, I will define a variable where it is being authored, right? So when it's created, or where I see it in source code, is where I'm going to create it. Now we come back to this function that you see over here, right? In a scope, this guy over here, right? When it's created, has scope, right? Because it's authored, right? Has scope. But what you don't know is that it's enclosed in these 2 brackets, which is add power. Add power has its own scope. But add power is not only in its own scope, but it is the inner function's lexical scope. And this function works and is 30 because of a concept called closure. Closure says when you are created, right, you have access to your surrounding scope. You have access to get control of the things that are the closest scope around you, right? So when increased power runs, it says, hey, I actually saw this inner function, right, being declared within add power, right? And in the inner function, or in this inner function, I've got something called by birth, but I don't know where by birth comes from. If I look at the inner function's scope, I realize that it comes from something called add power. And yes, add power actually does have by birth, because your engine goes to the innermost scope and says, hey, do we have by birth here? And it says no. But the outermost scope, and it goes to add power, and it says, do you have by birth here? And it says, yes, we actually do. And it grabs that value, which when we ran add power was 10. And that's how we get 30 instead of 15 or 35 or whatever, right? And that process is called closure. Are we together? Cool. The next part is currying, which speaks very closely to what you were talking about, and having to really like create functions and like in their own different state and like putting them together, tearing them apart kind of situation, and kind of decoupling how like difficult your touch points in like large function looks like. So currying is the act of converting a function that takes multiple parameters into a series of functions that only take one parameter. I'm going to say that again. Currying, right, is the act of converting a function that takes a lot of parameters and creating a series of functions that only take one parameter. Example, the total force, x force total strength. We have a function there that takes A, B, and C. Now, when I said I'm not going to talk about the libraries like Lodash and Ramda and all of that, here they become an exception because JavaScript doesn't have currying inherently, right? So in the act of this talk being functional programming that you can start using now without adding anything, this kind of fails. Because in order for you to curry a function, you will need help from any of the utility libraries that are available, being Ramda, being Lodash, or underscore, right? In this case, we call on Lodash, right? I have a function, or Lodash has a helper or utility function called curried. So after I've created this nice function of mine, I curry it. Né? And by just doing that, I'm now able to supply in that function that originally took 3 parameters, only 1, right? And then do that again, and do that again, and do that again, pass 2, pass 3, and all of that. Now, who cares? Why would I want to do this? Because it feels like it's too complex for me to start doing or using it now. The reason why you want to do currying is that when you really have a function that's doing way too much for its own good, it really does help to actually break that function apart, right? And tying it and putting it together bit by bit in such a way that it kind of contextually makes sense to you. So when I look at this code, right, it makes sense as to what it's doing because it's visible, it's right there, right? And I can put these things bit by bit. If ever I'm not ready or don't have the value that I need for this function to continue, I can pass one function, and I can pass the next, one parameter. I can pass the next parameter, and all of that comes together to actually create a holistic picture. It also helps with testing your functions. So if you don't have something that has been mocked somewhere that you need for this function, you can pass one of the function that it needs and see whether or not it does what you want it to do. And you continue, and you continue, and you continue. And yeah. And to the last or the end part of this is how it's easy to test. Now, I don't know if you guys have had the experience of having to mock something to death because it is calling a database, and it's going and calling some service. Before I actually write what I'm trying to test in that function, I am busy just creating objects that are going to be called in the function and all of that. So in here, instead of trying to iterate, right, your user inside this function, I can actually create another function called user search that goes in there and finds the ID that I'm looking for, right? And pass the output of that function into user. And all I need to do is just add a superhero into this array that I just iterated through. So if I were to want to test add squad member, right, I can just pass in an array that has the object that I'm looking for and pass in what I want to push to the array, and it will return a function to me. Easy, done, we can move on. And that's why this is so cool. So, thank you very much for listening to me. This is the end of my talk, and hopefully you guys can see how you can start using functional programming, or at least entertain the idea of the possibilities of using functional style of coding into your everyday JavaScript creation. Awesome. And the last thing I want to say is check out these sources, the book that I was telling you guys about. So, like, disclaimer on that functional JavaScript, it's English. Is very strong. So sometimes when you like reading, it's just like you just need to have like some dictionary situation going on, because I feel like he's too intense. So I created this in this particular order because like that is a lightweight. Like the Nathan Taylor is like high level, get the concept done, right? And Anjana like also does the same thing. She's like a YouTube video type situation. And once you've got those concepts and kind of have like a high level view of what they are, then this book will like deep dive on the concepts. And maybe then it will start making sense and putting things together. Cool. Thank you.